When Ferrari began testing their first fully electric hypercar, engineers hit a wall that had nothing to do with aerodynamics or battery life. They had to call in aerospace medicine experts from NASA because the car was physically too fast for the human brain to process. This diagram points to the exact root of the problem. On the left is the power curve of a traditional combustion engine, which sweeps up gradually. On the right is a modern electric motor. It delivers maximum torque at 0 RPM, hitting the wheels with an instantaneous, violent vertical spike of energy. That sudden strike of G-force hits the human vestibular system, the delicate structures in your inner ear that manage your sense of balance. The acceleration is so abrupt that the brain has no time to anticipate the movement, resulting in a momentary loss of situational awareness, similar to what fighter pilots experience in an aerial chugfight. Engineers are now racing against the physical constraints of the driver's own body. Ferrari's CEO, Benedetto Vigna, discovered this firsthand. During test runs in their 100, they needed to pinpoint the exact millisecond where extreme acceleration stops feeling exhilarating and forces the central nervous system into a state of panic. Using aerospace data, Ferrari developed a proprietary software solution called transversal acceleration modulation. Instead of dumping the battery's energy into the axles all at once, this system actively manages how power flows to the wheels. Look at this generated power curve. The software takes the harsh, vertical spike of raw electric torque and forces it to draw a sweeping, progressive curve. It artificially mimics the energy buildup of an analog combustion engine. By deliberately holding back peak power for a fraction of a second, the software tricks your inner ear. It buys your brain the critical milliseconds it needs to brace your body for the physical impact of the acceleration. They are intentionally manipulating the physics of the launch to make a 2.5-second sprint biologically digestible. This perceptual design extends to the cabin. To keep the driver spatially oriented, Ferrari brought in Sir Jony Ive, the former design chief at Apple, to rethink the interior interface. The design rejects the industry trend of massive, distracting touchscreens. Instead, Ive's team relies on heavy physical buttons and haptic feedback. They even engineered virtual gear paddles that deliver a tactile click and a micro-interruption in power delivery, giving the driver physical reference points for their speed. To keep the driver's senses grounded, the car refuses to pump artificial synthesizer audio through the speakers. The engineers chose to acoustically amplify the actual mechanical frequencies generated by the electric motors and inverters. They also integrated biometric sensors directly into the seat and the steering wheel. These instruments actively track the driver's heart rate and pupil dilation in real time. If the system reads acute physical distress, the car acts as an automated co-pilot and instantly scales back the power output to protect the person behind the wheel. But for those who want to feel exactly what the test drivers felt, rumors indicate the Luce will feature a setting dubbed NASA mode. Engaging it strips away all perceptual modulators, violently surging the raw, unfiltered 1100 horsepower from the 800-volt battery directly into the 4 independent wheels. Because of the physical toll this launch takes on the body, accessing this mode comes with an extreme condition. The driver must pass a live biometric health check through the official Ferrari smartphone app before the car will unlock the feature. Building an electric motor that spins incredibly fast is now mathematically simple. The true measure of automotive engineering today is building a system complex enough to respect the limits of the human nervous system. The Luce functions as a high-performance laboratory, testing the limits of how much speed a human being can actually experience. The global debut of the final design is scheduled for May 25, 2026, with deliveries rolling out of the Maranello factory gates by October. But the launch has already hit a legal roadblock. Mazda recently moved to register the Luce trademark, pointing back to a classic sedan they produced decades ago. This move has ignited a massive patent war, right as Ferrari prepares for production. It makes you wonder, if a car has to actively trick your brain just to keep you conscious, would you still dare to get behind the wheel? Let me know in the comments if you would brave the NASA mode. Make sure to subscribe, and I'll keep you updated on the trademark war and the final reveal.